So in the last video, we talked about the idea of losing energy as we convert it. And in this video, I wanted to sort of explain how to measure that idea. And so let's start by talking about efficiency in general. The general definition and equation for efficiency is the percent input converted to output. Input converted to output. And if that sounds general, I did that on purpose. It's supposed to sound general. Because this is true for all efficiency equations. If we go back to our mechanical advantage equation, it was percent efficiency equaled, the idea was anyway, the output divided by the input multiplied by 100. And so I can't stress this enough. This is the formula for any type of efficiency, whether it's the efficiency of energy, the efficiency of power, which we'll learn in later videos, or if we go back to mechanical advantage efficiency. But in this video, we're going to be talking about more specifically energy efficiency. And energy efficiency is basically the exact same formula, just specifically for energy. So the equation is eta, which kind of looks like this weird N with a long leg. It's the Greek symbol eta. Eta is equal to the energy output divided by the energy input. And of course, all of it's multiplied by 100 so we can get a percentage. And actually, let's go ahead and make a little note for ourselves that this is the Greek letter eta, so we know what it is, because it looks really weird. And that is, of course, just the symbol for energy efficiency. So just a little note for ourselves so we know what that looks like when we look back at our notes. But let's look at an example of losing energy as we do some form of work. And I like an example where we're squatting. And I like this example because this is actually a true story. Back when I was younger, I was working with a personal trainer, and he always told me that I could easily squat another 200 pounds, as strong as I am, if I would just be more efficient with how I squatted. So there's a picture of someone squatting some heavy weight. But yeah, his point was if I moved my body in a more efficient way, I would live up to my potential. Get it? A little energy joke. But let's be serious. Let's say that my legs put an input of, let's say, 50 joules of energy. Let's just keep everything simple. Leg input is 50 joules of energy. So I'm putting 50 joules of energy, or expending 50 joules of energy from my legs. And let's say the actual work output, the work done, is, let's keep this super simple, let's just say is just 30 joules of energy. So the question is, how efficient is this system? How efficient am I when I'm squatting? So what is the energy efficiency? Well, our formula hasn't changed. We just figured out what it is. It's energy out divided by energy in. So our output is 30 joules, we just said. That's the work being done, or the energy being expended, or the energy being put out, I should say. The energy I'm doing, energy I'm applying, is 50 joules of energy. And of course, to figure out what that number is, we would say, what's 30 divided by 50? We type this into our calculator and we get 0.6. And you might point out, well, Mr. Anderson, you forgot to multiply it by 100, which is what we have to do. Okay, well, let's go ahead and multiply it by 100. We'll say 0.6 times 100. And if you can't do that in your head, that's okay. That's what calculators are for. We get basically 60% efficiency in this system. And so what does that mean? Well, it means only 60% of the work that I'm putting into this, or the energy I'm putting into this squat, is actually being converted into the work of the bar being lifted.